Hi, so today's lesson is on linear inequalities, and we're going to extend that into word problems as well. So, the first thing I want to just reiterate and remind everyone is what is an inequality? Well, hopefully at this point we all know that an equation is something that has an equal sign. An inequality is a mathematical expression that has an inequality symbol, so greater than or less than, or greater than or equal to, and less than or equal to. So let's talk about a linear inequality. Okay, so a linear inequality is an inequality that involves a linear function. Okay, and so remember we talked about like linear equations and linear functions, the highest exponent of any of the variables would be 1. So again, we're not going to see linear inequalities that have exponents that are higher than 1, but let's look at an inequality and what it looks like as a word sentence and then the graph. So this means x is greater than 4. We always read an inequality based on the variable. So x is greater than 4. We would have an open circle at 4, and everything beyond 4 is a solution to the inequality. So if I asked you, name a solution to this inequality, you could say 5, you could say 5.5, you could say 100. It goes from x as 4, from 4 all the way to infinity, but it does not include 4. Whereas x is greater than or equal to 4, well, actually we would put a closed circle at 4 and go to the right because it actually includes 4. Then we've got x is less than 4, which means an open circle at 4 and everything to the left of it. And then x is less than or equal to 4, we'd have a closed circle because it does include 4, and then every solution to the left of it. When we write inequalities in this class for ease, it makes it much easier. It's not that you have to do it, but for ease, it's easier if you put the variable on the left. Every time. If you put the variable on the left, it will make it easier, and we want to make it easier. Okay, so let's look at solving and graphing an inequality. Okay, so our inequality is -3 times 2x minus 5 plus 1 is greater than or equal to 4. Okay, so we solve it like we solve an equation. Okay, so the first thing that in this situation we'd have to do would be distribute the -3 and simplify. So we would get -6 plus 15. We want to make sure that we don't forget we have a negative times a negative, plus 1 is greater than or equal to 4. Then I would do what I normally do. I'm going to combine like terms on the left side. So -6x plus 16 is greater than or equal to 4. Now notice I'm saying this out loud to myself. You should do that too when you're practicing these. All right, so now I'm going to subtract 16, and that's going to give me -6x is greater than or equal to -12. All right, now here's something that you may have to recall from algebra. I'm going to divide both sides by -6, but when I do that, when I divide an inequality by a negative, I have to change the direction of the sign. When I divide an inequality by a negative, I have to change the direction. Okay, so it's actually when you multiply or divide. When you multiply or divide, write this down, by a negative, you must, and I mean must, change the direction of the sign. So change the direction of the inequality. So you can see when I divided by 6 here, it was greater than or equal to, and it now has become less than or equal to 2. As a graph, that means that the solution to this would be I want every number from 2 to negative infinity. So -100, -1,000, -10,000. Any number that's less than or equal to 2 is a solution to this inequality. Okay, so let's just talk about at least and at most. These terms are going to come up in word problems, so I want to just define what they are and what they mean as an inequality. If I want to have something to be at least 5, that means I need it to be greater than or equal to 5, okay? So at least means greater than or equal to, okay? Greater than or equal to. At most means I want it to be no bigger. So that means less than or equal to. So at least is greater than or equal to, and at most is less than or equal to. All right, so how are we going to use this? Let's talk about this. The recipe for baking cookies states the cookies must be baked between 16 and 20 minutes. The baking time must be greater than or equal to 16 minutes and at most 20 minutes. Okay, so baking time. I'm going to let B equal baking time. Again, it's a word problem, so we need to set our variables. Okay, so the baking time needs to be greater than or equal to 16. And at most 20 minutes. So B has to be less than or equal to 20. Okay, well notice that in this instance, okay, I wrote 2 inequalities. So we're going to extend this idea of basic inequalities into something called a compound inequality. So I want you to think about B is greater than 16 and B is less than 20. Can I combine them? Can I combine them? Well, you can, using something called a compound inequality. Well, what in the world is this and what does it mean? Well, a compound inequality is an equality that you can actually write as 2 separate inequalities or as one inequality. So for example, this I call an and inequality because there's 2 different things that have to happen. It has to be B is greater than 16 and B is less than 20. An and inequality, you can actually put the B in the middle. If I put the B in the middle, okay, well then I know that B has to be less than or equal to 20. Now look at this. B's got to be greater than or equal to 16. So can I write it like that? Look how I put this together in one inequality. That's called a compound inequality. So that is telling me now if I graph this, well, if I graph it individually, let me do that first. If I graph it individually, I've got B's less than 20 or equal to, so I have that. And if I have B's greater than 16, so here's 20 and here's 16, I have that. The answer to the inequality is actually the overlap. It's everything in between because this is what has to happen. And it even said that the baking had to be between 16 and 20. When I write it as a compound inequality, the graph's actually written neatly for me because here's the 16, here's the 20. I have everything in between them. I want all the B's in between them. So a compound inequality is sometimes easier to see it, to see what we're talking about. All right, let's try one. The doctor told the mother that the expected weight, I should say weight, sorry about that, for the baby of her age was between 20 and 25 pounds. So that word between tells me that I can write it as a compound, and we call that an and inequality. Well, first let's write it as 2 distinct inequalities, okay? So I could say that x is greater than or equal to 20 and x is less than or equal to 25. See, to me, that's kind of confusing. It may not be to you, but to me, I've got these 2 inequalities. They're pointing towards each other. Like I just got a little confused with it. So as a compound inequality, when I think of between an and inequality, I've got x's between 25 and 20. And so this is just a nice way of looking at it, okay? Let's try another one. The teacher decided to separate his students and asked that they report to separate rooms to review their English exams. All students who have earned above a 90 or below a 60 were asked to report to a room for further instructions. Okay, so I'm going to say that X is the exam score. X is the exam score. Okay, can I write a compound inequality? Well, this one's slightly different. I want all the kids that earned above a 90. It doesn't say a 90, it says above a 90. So x is greater than 90. Or x is less than 60. Well, that one I actually can't combine into one. Why? Because it's one or the other. If I try to combine it, I can't put x in the middle because I don't want the things in the middle. So this is a compound inequality. It's two inequalities, but they are combined using the word or. Or is part of the compound inequality. Now let's graph that and see what it looks like. Okay, so here's 60. Here are the scores of 60. So I have less than 60 and greater than 90. So what you may notice is with the and inequalities, the compound where the x was between, everything was in between the 2 points. The graph was inside the 60 and the 90, but or they seem to be pointing outwards. And for the most part, they will, unless there's overlap. And we are going to be talking about that in class, okay? All right, so let's just review. And inequalities are written with the variable in between two inequality symbols. The inequality symbols are always going to be pointing to the left. You may have noticed that. And they're always going to be pointing the same direction. An or inequality would look something like this. Two inequalities with the word or in between them. Now, we solve them in a specific way. When it's an and inequality, it's called we solve everything simultaneously. So just like you'd solve an equation, we'd isolate the variable. So we would add 8, but we have to add it to all of the sides. So 3 sides of the inequality. So we're going to get 6 is less than 3t is less than 18. Then we divide all of the pieces by 3, and so we get 2 is less than t when it's equal to, thank you, less than or equal to 6. My graph, again, is every number between 2 and 6, just like that. All right, and these are less thans. Okay, or inequalities, we call them greater thans. Okay, we have 2x plus 3 is less than 5, or 4x minus 7 is greater than 9. So let's fix this. We are going to solve each one individually. So 2x, I've subtracted 3 to both sides, and I got 2. And then I divided both sides by 2, and I got x is less than 1, or plus 7 to both sides, add 7 to both sides, so 4x is greater than 16. Divide both sides by 4, so x is greater than 4. A graph of this, again, x is less than 1, open circle, because it doesn't include it, and x is greater than 4, open circle, greater than 4. The word or is part of my solution, so don't forget that. And so we have our 2 compound inequalities. All right, we're going to stop there, and we're going to be practicing this tomorrow together in class. Have a great day.